4.
Mr. Wakazashi, this is Aaron Beaty with the University of Florida Design Team, just reporting back to you with our our preliminary design for the pasta machine that you had ordered. As you can see pictured here is the basic pasta machine. There would be a conveyor belt up here that would feed the dough into this chute here by gravity. The dough would go down and then contact the rollers right in this area here, which would thin it out to 1 millimeter thickness. And then another conveyor belt would need to be positioned under the machine to carry away the final product. These are the basic dimensions as you see here. This is just a reference drawing to show you the general size of the machine as compared to a man of average height. And as you can see, it comes up to about waist high or so. This is a dimensional footprint of the machine as it would take up space on your factory floor. The black box has been drawn around all the outermost parts of the machine, and as you can see, we're looking at about 70 by 17 inches rectangular. We did some power requirements for the motor that would be necessary to run the machine. What we assumed is that you would need, the most amount of power you would need is enough to cause the rollers to slip against the dough to exceed the friction that was there. And experimentally determined radial load and coefficient of static friction that were used was 100 newtons and 0.2, and also a 94% efficiency rating on the gears for friction loss there. And the final number that we came up with is 0.282 horsepower is necessary to power the machine. This is the basic gearing configuration of the machine. There's a shaft that starts here, runs all the way through to this bearing on the end, and then there's another shaft that goes from here to here, and in these locations are pressed in bearings that are pressed into the housing, and here also, and then the motor shaft extends from here where the motor sits into the center of that gear. And so that's, and then here, of course, is the motor mounting pad where the motor could be placed. This is the bearing that we chose, and it was primarily chosen for a very large inner diameter that you see here, which will allow a very big, strong shaft to run through it. A shaft that would not allow any or very little twisting and yielding there, so it would allow for very high rigidity of the machine in general. Also, there's a set screw hole here, which will allow the bearing to clamp onto the shaft, and then the bearing will be pressed in the housing, as I said before, and this would hold both the gears and the rollers from having any axial movement at all. For the materials, we chose a very high strength metal for the gears to prevent fatigue failure there, and a 3/16 stainless steel to prevent corrosion and pollution of the food. We did some calculations to find out if the gears, the metal and the gears that we chose would achieve infinite life. And what we found is that the bending stress in the gear teeth has to stay below 99.64 KSI in order to achieve infinite life. And what we calculated was 10.11 PSI would actually be present in the bending stress of the gear teeth. So you essentially have infinite life there in bending of the teeth. Also, in the contact stress, or the stress on the surface of the teeth from the teeth actually touching each other, what we found is that we would need to be under 119.8 KSI in order to achieve infinite life. And what was actually calculated that would take place under the loads that we anticipate is 3.344 KSI. So again, rating from these two, there's infinite life on the surface of the gears from the contact stress of the gear teeth touching. The last thing that we would like to include is that we chose a bearing that had very high radial load capacity rating on it. And essentially what this means is that for our calculations that it has a life of around 17,000 years. So again, these bearings are going to have infinite life. Coming down the home stretch here, we look forward to working with you, refining this preliminary design to its final stages for production. And please contact us if you have any questions or concerns. And again, thank you very much for your business. Have a nice day.